Now in this lab, we're going to use Dockerfile to build a container image, have the container image hosted on the ACR, use AKS to pull the image and host both an internal Nginx service and external Nginx web services. All right. So the first exercise, we are going to configure the ACR. Okay. Steps involved. This is all done through the Bash, Cloud Bash. Okay. So here. So this creates a resource group called AZ500-Lab 09 in East US. Okay. Let's make sure the resource group is indeed created. This creates the ACR resource. Okay. All right. So you see that the ACR resource name is AZ500, and these are randomly generated numbers. Okay. Now when you use the AZ ACR list, it's going to say that admin user enable equal false. So that means our ACR will rely on Azure AD principles for login rather than an ACR username and password. Okay, so whoever wants to access to the images must authenticate through Azure AD to obtain an access token. So that means when AKS try to pull the image, AKS must be associated with a service principal. A service principal then obtains the access token to the ACR. Now, in this bash session, because this bash is started from the Azure portal, this bash handles our access token. So every interaction against the AZ-ACR, using the AZ-ACR command to interact, behind the scenes submits our access token. All right. So here we create a very simple file, Docker file. It contains only one line, from Nginx. So we're just basically making a clone of the Nginx container. This command here pulls up the ACR name that we've created earlier. Now the instruction says this builds an image. Actually, what this does is that it pack up the Docker file and everything in the local directory and creates an ACR build task. The ACR build task is one of the services provided by the Azure Container Registry. For a situation like this, we have Bash, and this Cloud Shell has minimal capabilities. So it's not capable of running Docker daemon to actually build a container. So instead, we can collect our source code, prepare a Docker file, and have the Azure Container Registry build the image for us. Save us the trouble of pulling image locally, build it, and then send it. So in one go, we're sending the source code to let ACR build it for us. All right. So it will echo back all the steps it took. But now these are happening here in the Cloud Shell. It's happening remotely. Now once that is done, we can navigate to the resource group and take a look at that. So here's the level 9. Here's container registry. Under repositories, okay, so the sample Nginx is the name of the tag that we gave when we queued up that job. Okay. All right, so our tag is v1. So we should have one image v1 in the repository. Yep. All right. So this is the v1, and this is the manifest of the image. All right. Next, we're going to create a Kubernetes service. All right, we're going to continue. Choose a node pool. We're going to disable scale set and disable virtual nodes. All right, we'll have one node for our Kubernetes cluster. All right, now it's important to observe that we will be creating a new service principal. Now, because this principal will be created for this Kubernetes cluster, this becomes the identity which external Azure services are interacted with will be from this service principal. So if we want to grant AKS permission, we got granted to this service principal. All right. Now, service principal will remain after you delete the Kubernetes cluster. If you choose the radio button system assigned manager identity, that means if you decide to delete this AKS, that identity will go away. All right. So we're going to create this default service principal. All right. And now we are going to enable our back services. All right. So let's take a look at the networking. All right. So we're going to go to advanced. Now, using the advanced, we're able to give each pod its own private address within the VNet. So this requires the container network integration, or the CNI. Okay. Now make sure that DNS prefix, make sure you add your initial to it, so it will be globally unique. It will not conflict with any other service. All right, we're going to turn off container monitoring from log analytics. All right, so the process of creating this AKS could be anywhere from a few minutes to 10-15. Alright, so the deployment is completed. Let's go back to the mesh. To communicate with Kubernetes cluster, you must have credentials for it. And because we have already signed into the Azure using the Cloud Shell, we can download the credential to our cluster. And to make sure kubectl, which is the command to work with the Kubernetes, can give us our node status. Now earlier we had a service principal created for our AKS. So now our next command will attach our container registry so our Kubernetes cluster can access those images stored in the ACR. So notice AKS update attach ACR. So behind the scene, the service principal are given permissions to access the container registry images. Now specifically, the role, the RBAC role, is called ACR pull, okay, which allows the Kubernetes cluster the permission to pull image. We are able to create a job and upload image because we have ACR push, or at least the contributor permission. Okay, so both of those have the ability to push and create new image onto the ACR. Now keep in mind that attach ACR simply make our AKS a ACR pool, RBAC member. Alright, so let's just double check our ACR name. Now we're going to use this icon here to upload the 2 YAML file provided by the lab. So click on that, select upload. Now you'll find the 2 YAML file in lab 09. Alright, so we got the external file. We're going to have to upload one file at a time, and here's the internal file. Alright, so both files are now available. And this YAML file defines a Kubernetes service. So let's take a quick look. Alright, so I'm going to open up the editor by clicking on this icon. And this is the external service. Now this external service defines a deployment by pulling an image from our ACR, and we need to update this so it uses our actual ACR name, which is this guy. Alright, so this will be the image path, okay, the container image. Now we will define an external load balancer service that will take port 80 and send into our container port 80. Alright, so let's go and save this. We're going to submit this YAML file so our Kubernetes can stand up the service. Because we asked for a load balancer service behind the scene, it will allocate a external public IP, but it will take some time. Alright, so now the external IP has came up. Alright, if the container has started up successfully, we should see the Nginx welcome page. Alright, so it may take a few minutes for the Nginx to fully start. So take the public IP and refresh. After about 2-3 minutes, we get the welcome to Nginx web page. Alright, now AKS can also deploy services that is only available within the cluster. So our next service that we want to deploy will be an internal service. Alright, so let's take a look at the definition of the internal service. The deployment behaves exactly the same, so we need to deploy. Oops, just realized we forgot to replace that guy there. Alright, so yep. So make sure you edit this to include the correct container registry. So there's that. Save. And then we need to send this command out again. Send this document to update our deployment. All right. So you'll see that deployment has been reconfigured to point to a different image, to point to a correct ACR. All right. All right. So this service is a service only available internally. Okay, so the annotation used to describe that the load balancer internal true. So the service we're requesting is internal facing. So there is no external access to the service. So next, we're going to drop into one of the pod and use that pod to access the internal IP of the service. So at the moment, there are two pods. One that is the external service, and one is the internal service. All right. So we're going to run a bash. All right, so we're going to have to copy that, paste it, and then we need to specify the pod name. So we're going to connect to this external pod. All right. Got to complete the command. All right. So the execute means I want to connect to I want the pod to execute a bin bash. And let me connect to it here. So once we run this command, we will enter the bash of that container pod. All right, and here we're going to do a curl to access the internal service. So this is the internal IP. All right, so there you go. So now we're accessing the internal IP for the Nginx. All right. So this demonstration shows you that with an AKS, you can create services that's publicly accessible. Now, although they are publicly accessible, typically you may want an API management service to handle many of the security needs, token verifications, HTTPS handling, and keep these Nginx behind these type of API management gateway. All right, so that concludes Module 9, Lab Activity.